Welcome to our tuition classes. We are doing similarity extra sums. We are on the lecture 2. Let's just have a look at this. Triangle ABC and triangle DBC have a common base BC. This question number 1. Triangle ABC and triangle DBC have a common base BC. Now this word common base, children, is a hint for us. Okay? Triangle ABC and triangle DBC have a common base BC. Okay, and what I want to prove, area of triangle ABC upon area of triangle DBC equal AO upon DO. But then, listen, when the triangles have a common base, equal base, we have learned ratio of the areas property, ratio of the area should be equal to ratio of the corresponding heights. So the heights किधर है? जैसा triangle ABC को देखो बच्चे लोग, triangle ABC, ऊपर वाला triangle ABC, उसका height किधर है इधर? नहीं ड्रॉ ही नहीं किया और BC बेस मांगता है मतलब if the height is drawn on BC then only BC becomes a base. So what I do, I draw a height on BC, okay, of triangle ABC. When you can see from I draw height, okay, this is my construction. Okay, this is my construction. I'll just dotted line, I'll make it dotted line, okay. Not getting it. And for DC, okay, we'll make it completed as a dotted line. You can see actually this one, this is draw segment AD perpendicular to BC. So the moment AD I draw, AD becomes the height of triangle ABC. In the same way, children, if I draw DQ, okay, from D, if I draw a perpendicular, okay, like if I draw a perpendicular from D, okay, if I draw a perpendicular from D, that will become the height here. Can you see, if I draw DQ perpendicular to BC, so DQ is the height here. Here AD is the height, here DQ is the height. AD is the height, so BC becomes a base for triangle ABC. DQ is the height, so BC becomes a base for triangle DBC. Now it's right to say they have a common base. So naturally, we want ratio of the areas. So can I say, children, prove, okay? Can I say area of construction? First, whenever you do a construction, you better show it separately. You better write it down, children. That has marks. If you don't write construction, your marks will go, okay? So better say that construction what you have done. So first step is construction, okay? What is the construction I did? Draw segment AD perpendicular segment BC and also draw segment DQ perpendicular segment BC. Okay, so now we can go for the proof for it, children. You can see here, area of triangle ADB, ABC and DBC have a common base. This triangle ABC and triangle DBC have a common base, So ratio of the areas of the triangles having equal bases is equal to ratio of the corresponding height. So area of triangle ABC upon area of triangle DBC, these two triangles, they have equal bases. So the ratio should be equal to the ratio of the corresponding heights, AD upon DQ. Okay, I call this as 1, and the reason for this, we can write the areas of the triangles, areas of two triangles having equal heights, having equal bases are proportional to corresponding heights, Okay, areas of the two triangles having equal bases are proportional to corresponding heights. But then, just have a look. Area of triangle ABC upon area of triangle DBC is what we want in our answer. It should be equal to, I got AD upon DQ, whereas here I want AO upon DO. Matlab, I have not got an answer. I have not got an answer. So somehow this AD upon DQ, this AD upon DQ what I got, I'll rub this, okay? AD upon DQ what I got here, I want it to be replaced by AO upon DO. हमें दोनों को इक्वल दिखाना पड़ेगा तो ही रिप्लेस कर सकते हैं एडी अपॉन डीक्यू को इक्वल कैसे दिखा सकते हैं दो रेशियो को इक्वल दिखाने का तरीका क्या है दो रेशियोज को इक्वल दिखाने का तरीका क्या है बेटा just prove the triangle similar prove triangle similar then only you can get prove triangles similar then only you can get ratios equal. So how to get the triangles, children? That also is very simple. You want AD and AO, am I right? So look at AD and AO. They should belong to one triangle. So you can clearly see one triangle ADO here. And DQ and DO should belong to the other triangle, DQ and DO. DQ and DO, DQ and DO belongs to the other triangle DQO. So naturally, children, look at these two triangles. Don't agree, I'll prove these two triangles similar in triangle ADO. Okay, and triangle DQO. Just have a look at these two triangles. To agree, children, angle ADO, congruent angle AQO, DQO, congruent triangle DQO. What's the reason, children? You can see here, triangle DQO. The reason is very simple, children. Okay, what? Angle ADO, congruent angle DQO. What is the reason, children? Each is 90 degrees. Each is 90 degrees. Okay? Perpendicular we are done. So they are 90 degrees. So making 90 degree angles of BC. Then children, this is very simple. Angle AOD. Congruent angle DOQ. What's the reason, children? Vertically opposite angles. Vertically opposite angles. Vertically opposite angles. So now what will happen, children? Please have a look at this. So both the triangles, triangle ADO, similar triangle DQO by AA test, children, by AA test of similarity. Got it? Now, once the triangles are similar, children, the ratio of the corresponding sides are equal. So can I say, पहला दो letter क्या है AD, तो the पहला दो letter DQ आएगा, equal. Second and third letter DO upon QO. Equal AO upon DO from the name of the triangles. I got this, okay? Corresponding sides of similar triangles. Corresponding sides of similar triangles. Corresponding sides of similar triangles. So now when we look at it, children, look, I want AD upon DQ first ratio and AO upon DO the third ratio. So I rewrite AD upon DQ equal AO upon DO, and I call this as theta number 2. Now can I replace this AO upon DO by AD? So you can see, therefore, area of triangle ABC upon area of triangle DBC. I'm rewriting this theta number 1, okay? But in place of area upon DQ, what is area upon DQ equal to AO upon DO? So equal AO upon DO. Can you see this, children? Reasonings from 1 and 2. So I think I got my answer. A very simple sum, children. Very easy sum. Okay. We go to the next sum. Question number 2, children. Given in this triangle ABC, can you see the big triangle ABC? XY is parallel to BC. I mark them with the arrows indicating that these two are parallel. XY is parallel to BC. XY is parallel to BC. So don't you realize, children? I told you just now, whenever, I mean, in my first lecture, I told you, whenever you see in a triangle, okay, a segment is parallel to a side of the triangle, children, then two options come to your mind, okay? One option is, children, you can think of basic proportionality theorem, okay? What is the basic AX upon XB equal AY upon YC? And another option that should come to your mind is, there are two triangles. One is triangle AXY and one is triangle ABC. I can easily prove them similar. Like corresponding angles for parallel lines, and this is a common angle. So naturally both the triangles are similar. So naturally, the moment you see this condition, XY parallel BC, a line is intersecting the two sides and parallel to the third side. Remember, two options comes to your mind. One is of BPT and one is viewing the two triangles similar. Now, in this case, I will go to prove the two triangles similar. Because once I prove both this big triangle AXY and ABC is similar, from that I'll get that ratio of the corresponding sides are equal. That is AX upon AB equal AY upon AC. I prove this big triangle similar, AXY similar ABC. And if they are similar, the ratio of the corresponding sides are equal. So I will be taking AX upon AX is the side of the small triangle upon AB, the side of the big triangle, equal AM side of AY side of the small triangle upon AC. Then corresponding sides are similar triangles. And remember this AY, I can replace it as AY is twice AM and this AC is twice AM. So what will happen? AX upon AB equal twice AM upon twice AM. 2 gets cancelled. So AX upon AB equal AM upon AM. AX upon AB equal AM upon AM. AX upon AB equal AM upon AM. So a triangle देखो AXM or ABM. AX upon AB equal AM upon AM है then angle A is an included angle. So I can easily say both the triangles are similar by a test of SAS test of similarity. So I'll start with the proof here. You can see children, very simple, okay? I want to prove XY parallel BC है तो naturally पहला बड़ा triangle similar. जब भी मैंने बताया children, जब भी आप parallel lines का मदद से corresponding angles equal लेके आते हो तो आपको separately दिखाना है. So I start my proof with this segment XY parallel segment BC. What are the reason children given? Okay, XY parallel segment BC given. On transversal, can you see this transversal? On transversal, which transversal I'm going to talk about? AB transversal, okay? Can I say angle AXY, angle AXY, congruent angle ABC. What the reason, children? Corresponding angles for parallel lines. What I can say? Corresponding angles for parallel. Corresponding angles theorem, you can say. Okay, I'm so sorry. You can just say corresponding angles theorem in short. Okay, what you can say? I call it as statement number 1 because I'm going to use it. Statement number 1, and I'm going to say corresponding angles theorem. Corresponding angles theorem. And now you can see, children, because these angles are congruent, I can easily prove the two triangles similar. In triangle AXY and triangle ABC. Okay, angle AXY is congruent to angle ABC, I'll say from 1. From 1, okay? Then I can say angle A is congruent to angle A. It's a common angle, children. So both the triangles are similar. Triangle AXY is similar to triangle ABC. The reason for it by a test. Okay, now since these two triangles are similar, children, from here I'm going to get the information for proving the second two triangles similar. See what information I get? I purposely take therefore AX, first two letter AX upon AB is equal to XY upon BC I don't want is equal to third letter AY upon AC. Statement number 2, what I can say, corresponding sides of similar triangles. Corresponding sides of similar triangles. Corresponding sides of similar triangles. And now you can just have a look. This AY is twice AM, children. The reason is very simple. Statement number 3. M is midpoint of AY. M is midpoint of AY. Then children, this AC, you can just have a look at AC. What is AC? Twice AN. AC is twice AN. Reason, statement number 3. This was 3. This is statement number 4. Reason, N is midpoint of AC. And now I can change this AY and AC, children. Therefore, AX upon AY, AB equal, what will happen? Twice AN upon twice AN. Can I say, call this as statement number 5 from 2, 3, and 4. And now this 2 and 2 gets cancelled, children. So now you know this AX upon AB equals AM upon AN. So I can easily prove those two triangles similar. Like in triangle AXM and triangle ABN. Got it? AX upon AB equal AM upon AN. Can I say from 5? Can I say, children, here, let's have a look at this. Here, you can see, children. I'm going to now write it here, okay? You can see this angle A is common to angle A. Common angle, children. So can I say, children, both these triangles are similar by SAS test of similarity? The triangle AXN is similar triangle AXN by SAS test of similarity. So the first part of the proof is over. First part is over, children. Now we have to go to the second part. The second part is the easiest. I want to prove XM parallel BN. So naturally, I'll say this angle AM, okay, angle AMX, congruent angle ANB, angle AMX, congruent angle ANB. What the reason, children? Corresponding angles of similar triangles. Corresponding angles of similar triangles. Corresponding angles of similar triangles. But look at these two angles, okay? But they are also corresponding angles, but these are also corresponding angles for XM and BN, for segment segment XM and segment BN on transversal, when you look at it, on transversal AC. Can you see transversal AC? So can I say therefore your segment XM is parallel to segment BN by corresponding angle test for parallel lines. So I hope people have understood me actually. Everybody must have got it. Okay, I'm so sorry, children. I didn't properly plan the way of writing how much space is required for it. So I had to squeeze little, but I'm sure everybody must have followed it. Okay, everybody must have followed it. Okay, you're continued here. A very simple sum, children, but only thing people get frightened looking at the question. Okay, they should try to read it twice, thrice. It automatically gets into the mind. You get ideas also automatically. Okay. Question 3, children. A very simple question in the form of a rider. It is prove that corresponding medians of two similar triangles are proportional to their corresponding sides. याद रखो बेटा, जब भी वर्ड प्रोपोर्शनल आया कुछ समझता नहीं है, मीनिंग समझता नहीं है, ऐसा कुछ नहीं है. Just have a look here. This is R proportional. Got it? These two words, R proportional to. उसका लेफ्ट हैंड साइड में क्या है? करस्पॉन्डिंग मीडियंस ऑफ टू सिमिलर ट्रायंगल्स. राइट हैंड साइड में क्या है? करस्पॉन्डिंग साइड. से आर प्रोपोर्शनल टू को निकाल के मैं रेशियो वर्ड यूज करूंगा. देखो अभी whenever r proportional to रहेगा मतलब क्या होता है उसको देखो. रेशियो ऑफ द मीडियंस ऑफ टू ट्रायंगल्स, similar triangles, is equal to ratio of the corresponding sides. Ratio of the medians of two similar triangles is equal to ratio of the corresponding sides. जब वर्ड रेशियो यूज करते हैं वर्ड प्रोपोर्शनल यूज नहीं करना. रेशियो ऑफ द मीडियंस ऑफ टू सिमिलर ट्रायंगल्स इज इक्वल टू रेशियो ऑफ द करस्पॉन्डिंग साइड. मतलब ये क्वेश्चन बराबर एनालाइज करेंगे तो आपके पास दो सिमिलर ट्रायंगल रहने चाहिए. सब मैंने ड्रॉ किया है दो सिमिलर ट्रायंगल का पिक्चर and उसका corresponding medians मिलता है. So you see here, suppose AD is a median here, AD is a median here, PS is a median. Suppose AD and PS are the medians, okay? You know, median is a segment that joins the midpoint of a side and the opposite vertex. Okay, median is a side which joins the midpoint of a side and opposite vertex. Now देखो ये corresponding medians है क्योंकि they are drawn on corresponding sides. ये दोनों triangles similar है. BC और QR corresponding sides है. उनके ऊपर एक medians draw किया गया है, so they are called corresponding medians. So ratio of this corresponding medians, you have to show it is equal to the ratio of the corresponding sides of these two triangles. So simple, children. I'll make you understand. See, I have drawn the picture. So I'm going to write given now, okay? Whenever a question comes in a rider form, children, you should understand, okay? You have to draw the picture for it. You have to write given, okay? So what is the given, children? First thing I'll say two similar triangles. What is given? Triangle ABC is similar triangle PQR. Second, children, segment AD and segment PS are the medians. Got it? Can you see they are corresponding medians because they are drawn on corresponding sides. BC and QR are corresponding sides. Okay? And what you have to prove that? Prove that the ratio of the corresponding medians, this AD upon PS is equal to AB upon PQ is equal to BC upon QR is equal to AC upon PR, ratio of the corresponding sides. So simple this proof is, children. Okay, you have to show this ratio of the corresponding medians is equal to ratio of the corresponding sides. So simple this proof is. Let's have a look at children. What I do, पहला समझो. ये तीनों रेशियो तो इक्वल है ही. ट्रायंगल एबीसी सिमिलर ट्रायंगल पीक्यूआर ये तीनों रेशियो इक्वल है. तो ये एडी अपॉन पीएस किसी एक को साथ इक्वल दिखा दो. एडी अपॉन पीएस को एबी अपॉन पीक्यू के साथ इक्वल दिखा दो. That means I want to like to prove separately AD upon PS is equal to AB upon PQ. क्योंकि ये तीनों रेशियो तो इक्वल है ही. AD AB upon PQ because the triangles are similar. लेकिन AD upon PS को इक्वल टू AB upon PQ कैसा आएगा? तो I told you children, रेशियो तो जब भी इक्वल दिखाना है तो आपको दो ट्रायंगल को सिमिलर प्रूव करना है. ट्रायंगल कैसा ढूंढने का? न्यूमरेटर्स गिव यू वन ट्रायंगल AD एंड AB. ओ ट्रायंगल ABD. गॉट इट? और ये ट्रायंगल किसके साथ सिमिलर मांगता है? PQS. लेकिन अभी कैसा होगा चिल्ड्रन? मीडियन तो साइड को बाइसेक्ट करता है. तो समझो ये ट्रायंगल सिमिलर मुझे कैसा मिलेगा? आई थिंक विद द हेल्प ऑफ SAS टेस्ट. हाउ? वी जस्ट सी. फर्स्ट आई विल से इन माय प्रूफ द बिग ओरिजिनल triangle ABC is similar to triangle PQR. See how I thought. Medians are again my hints. You see, once the triangles are similar, you know children, AB upon PQ equal, BC upon QR equal, AC upon P are corresponding sides of similar triangles. This is your first, all three ratios corresponding sides of similar triangles. Now listen children, AD is a median, मतलब D midpoint हो गया BC का. मतलब ये BC जो है वो 2BD है बेटा. ओके, और ये जो QR है वो क्या है बेटा? ट्वाइस QS है. That means मैं क्या कर सकता हूँ चिल्ड्रन? देखो बीसी का जगह में 2BD लिख सकता हूँ सेकेंड रेशियो में। बीडी का जगह में बीडी का जगह में दिस इज 2, दिस इज 3, दिस इज D is midpoint of BC. And this is Q is midpoint, S is midpoint of S is midpoint of segment QR. That means what am I going to do, children? I'm going to write this AB upon, please have a look here, AB upon PQ. I'm going to write AB upon PQ equal the second ratio BC upon QR का जगह में I write 2BD upon 2QS. Okay, reason is from, this is statement number 4, from 1, 2, and 3. And you know, children, this 2 gets cancelled. Also, just have a look at this angle B. So ultimately, I got AD upon PS. Sorry, this AB upon, therefore I got, now look at this triangle. This angle B and angle Q are also congruent, I can say. Angle B, congruent angle Q, corresponding angles of statement number 5, corresponding angles of similar triangles. And now you can prove the two small triangles similar in triangle ABD and triangle PQS. Just have a look at these two triangles, children. Can I say AB upon PQ equal BD upon QS? Can I say, children, from 4? Can I say angle B, congruent angle Q, from 5? So don't you realize both these triangles are similar? Triangle ABD is similar to triangle PQS by what test, children? By SAS test of similarity. Now, why did I prove this triangle is similar? So that I can say corresponding sides are in proportion. What is that? AB upon PQ equal BD upon QS equal AD upon PS. I purposely call this as statement number 6. And say corresponding sides of similar triangles, corresponding sides of similar triangles. And now look at your statement number 1 and 6, children. I think you're getting your answer. This AD upon PS is AB upon PQ, and AB upon PQ is equal to all the ratios, okay? The only thing I have to write AD upon PS first is equal to AB upon PQ is equal to BC upon QR is equal to AC upon PR. So don't agree reasoning from 1 and 2. So you can clearly see, children, I've got a ratio of the corresponding medians of two similar triangles is equal to ratio of the corresponding sides. Okay, very simple question. We go to the next question, children. A very simple question. Prove that if the areas of two similar triangles are equal, then the triangles are congruent. You know, children, what is given is the areas of two similar triangles are equal. When the two triangles are similar, and the areas are equal. What is given to us is two triangles are similar. Triangle ABC is similar triangle PQR. Areas of two similar triangles are equal. When triangle ABC is similar triangle PQR, area of triangle ABC is equal to area of triangle PQR. And what did you prove, children? Prove that the triangles are congruent. Prove that the triangles are congruent. Triangle ABC is congruent to triangle PQR. You have to prove the triangles are congruent. Prove the triangles are congruent. Areas of two similar triangles are equal. You have to prove the triangles are congruent. Very simple, children. Very easy. Okay. So how am I going to go about doing this, children? So please here, I'll just draw a picture just for the sake of understanding. Without picture also we can draw it. Without picture also we can prove it. Suppose these are the two similar triangles. These are two similar triangles. Okay, the areas are equal. The two similar triangles, the areas are equal. I should draw it identical. I am not drawn it identical, but remember, I should draw it identical. Okay, these two similar triangles, the areas are equal. So what I do, first I say triangle ABC, similar triangle PQR. Triangle ABC, similar triangle PQR is given to us. Got it? So now areas are equal. So what I do, area of triangle ABC upon area of triangle PQR. The ratio of the areas of two similar triangles. Because the area word has come, I think of this theorem. The ratio of the areas of two triangles, similar triangles, is equal to ratio of the square of the corresponding sides. AB square upon PQ square equal BC square upon QR square is equal to AC square upon PR square. This is the reason. Please have a look. I called it statement number 1, and by theorem of areas of similar triangles, by theorem of areas of similar triangles, areas of similar triangles. Now you know one thing, children, that area of triangle ABC and area of triangle PQ are equal. Area of triangle ABC and area of triangle PQR are equal in areas. That areas are equal. Okay, the areas of these two triangles are equal. Area of triangle ABC is equal to area of triangle PQR. So what will happen, children? These two are equal. Say number 2 given. So naturally, correct, these two ratios, this ABC and PQR get cancelled. Therefore, 1 upon 1 is equal to AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square, 1 upon 1. Can I call it from reasoning from 1 and 2? Because this area of triangle ABC and area of triangle PQ are equal, they are getting cancelled, so 1 upon 1. So now we see. Therefore, AB square upon PQ square equal. Can I say like this? AB square upon PQ square equal 1 upon 1. Therefore, AB square equal PQ square. Therefore, AB equal PQ. Similarly, BC equal QR and AC equal PR. So now you can see, children, we can say these two triangles are congruent by SAS test. So in triangle ABC and triangle PQR, in triangle ABC and triangle PQR, you can say segment AB is congruent to segment PQ. Segment AB is congruent to segment PQ from one. Segment BC is congruent to segment QR from 2. Segment AC is congruent to segment PR from 3. Therefore, triangle ABC is congruent to triangle PQR. Can I say? I'm writing it here. Children, I'm completing in last line in this column, okay? Therefore, triangle ABC is congruent to triangle PQR. Triangle ABC, congruent triangle PQR by SSS test, by SSS test. So you can see here, children, if the areas of two similar triangles are equal, then the triangles are congruent. Question number, this is my question number 4, okay? The line cuts, what is given? A line cuts two sides, AB and AC, in points P and Q. A line cuts AB and AC in points P and Q. You want to prove that area of triangle, please have a look at it. Okay, you want to prove that area of triangle APQ upon area of triangle ABC area of triangle APQ upon area of triangle ABC equal AP upon AB, AP, this AP into AQ, what is upon AB into AC, AB upon AC. What is, you want to prove all this? What do you have to prove? AP, area of triangle APQ, area of triangle APQ upon area of triangle ABC equal AP into AQ upon AB into AC. Product of the sides AP and AQ upon product of the sides AB and AC. So how I go about, children? So what I do is, children, area word has come and neither I can prove both these triangles similar. So I think of only the first theorem. What is that? The ratio of the areas of two triangles having equal heights is equal to ratio of the corresponding ratio of the areas of two triangles having equal heights is equal to ratio of the corresponding bases. So we construct here. What I do, I draw segment, BQ, draw segment BQ. Now see the proof. So simple the proof is, children. Just 4 lines, okay? I would like to get AP and AB first. Can you see AP and AB? AP upon AB. So look, the moment I draw this, draw segment BQ, the moment I draw this, you can see this triangle APQ, which you want, and triangle ABQ. Of course, ABQ is not there. That means ABQ is not there in the answer, but I don't want ABQ in my answer, but I use it here. APQ and ABQ have equal heights. People can see, children, they have a common vertex Q and the opposite sides AP and AB lie on the same line. Whenever you see this condition, common vertex, the opposite sides lie on the same line. Common vertex. The opposite sides lie on the same line. They have equal heights. So naturally, area of triangle APQ upon area of triangle ABQ will be equal to, what it will be, children? Will be equal to AP upon AB. Can I say, statement number 1, reason is areas of triangles having equal heights are proportional to corresponding bases, okay, children? Corresponding bases, okay? We have learned it. Now listen, children, I got AP upon AB. I would like to get AQ upon AC. How to get AQ upon AC? AQ upon AC, the whole reason AC. AQ upon AC. AQ upon AC. So you can see here, children, I'm not doing anything in any extra construction, but look at triangle ABQ and look at triangle ABC. Got it? They have a common vertex B, and the opposite sides AQ and AC lie on the same line. So they have equal heights. Okay, both these triangles have equal heights. So again, area of triangle ABQ upon area of triangle ABC. When you look at this, correct, ratio of the areas of two triangles is equal to ratio of the corresponding bases, AQ upon AC. The other ratio, AQ upon AC, also I got it here, children, statement number 2. And the reason is same, children. Areas of triangles having equal heights are proportional to corresponding bases, So now what am I going to do, children? I'm going to multiply 1 and 2. Multiplying 1 and 2. So what will happen, children? Area of triangle APQ upon area of triangle ABQ into area of triangle ABQ upon area of triangle ABC. I'm multiplying both the statements. So here it will become AP upon AB into AQ upon AC. And now you can see ABQ gets cancelled. So what are you left with? Area of triangle APQ upon area of triangle ABC is equal to AP into AQ upon AB into AC. The answer, what you want, we call it, children. Okay, children?